So remember, we had an RDD of these person objects. We did people.forEach print line. So the question was, what happens? Well, on the driver, nothing happens. Why might that be? I'll give you a hint. For each is not a transformation. Remember that for each is an action, and it has return type unit, so it's a side-effecting thing. Therefore, because it's an action, it's eagerly executed on the executors, and it's not being executed on the driver. So any calls to print line that happen inside of this for each thing end up happening on the individual worker nodes. So then whatever this print line is doing is being executed on the worker nodes, and it's going to the standard out of the worker nodes, which you can't see if you're looking at the standard out of the master node that you're on. So basically what this does is it prints lines on the workers that you can't see because you're sitting on the master. Okay, what about this? The second example here. So what if we have this RDD of people and we do people.take? What happens? Where will the array of person representing first 10 end up? Well, by now I think you'll guess the driver program, because in general when you execute an action, it involves communicating data back from the worker nodes to the driver program. So what you do here is you're telling the executor nodes to do this computation and to send it back to the driver nodes. So running an action actually sends data back to the driver nodes. So what you're doing is you're giving an order to the worker nodes to do some work, and then the work nodes are sending their data back to the driver node. So the driver program is the one that has this array of 10 person objects. So the moral of the story is to make effective use of RDDs, you really have to understand a little bit about how Spark works under the hood. In particular, you have to know the anatomy of a Spark job. You have to know that there's something called a driver program, and that's sort of the brains of the application, and that a bunch of work is being farmed out to worker nodes and executors all over the place, right? And due to this API, which is mixed, eager and lazy, it's not always immediately obvious upon first glance which part of the cluster a certain line of code might run on. For example, transformations. So transformations are queued up, and then when an action comes along, then all of that stuff that got queued up gets optimized by the driver program, sent to the worker nodes, and then the worker nodes send something back to the driver node. So when you write a line of code like for each, you really have to think about where that code is going to execute. If you write for each and you want to do some for each print line to see what is going wrong with your data set, you're not going to see the result of that because that's being executed on the workers. So you really got to think about where your code is executing. It's on you to know where that code is executing. So remember, even though RDDs look like regular Scala collections upon first glance, unlike Scala collections, RDDs require you to have a good grasp of the underlying infrastructure that they're running on. That's the takeaway for this session.